Hi, welcome to another edition of Engineering with LEGO Bricks and Robolab. I'm Eric Wong, and I'll be your host. Okay, let's talk about jumps. This is a method of getting a program to repeat a certain set of the program. So I've got a simple program here, a chunk of program I've pre-written here that says turn motor A on, wait for 1 second, turn motor A off, and wait for 1 second. So actually you can see that 99% of the time is spent on the wait for. So it turns the motor A on in a split second, then it waits for 1 second. Turns motor A off, that takes a millisecond, then waits for 1 second. So most of the time, actually about more than 99% is spent waiting. But let's say we want to repeat this silly little piece of code over and over and over. I can go into my structures, on my jumps, do my jump subpalette, and I can actually go in and wire in. So I'll wire those in a little bit, and I'll see why in a second here. And this would get a program to repeat if I had wired it in. So this comes along, and the land is basically ignored. In text code, it's a line number, so it's basically ignored. Comes through, turns motor A on, then turns it off, and then jumps. This is the same as a goto. So you can think of it jumping. The program jumps up. Where does it come down? Well, it comes down wherever the land is. In this case, it would repeat this section of code over and over and over. There's nothing to say that you have to jump backwards. I could also jump forward in the program, for example. I can come here and start. It would jump up, jump down, and end, so the program wouldn't do much, but you could do that. It is indeed possible to do that. Now, there are a couple things which don't make much sense. Having two lands, for example, doesn't make much sense because you jump up and who knows where it's going to come down. You have a choice of two lands, so it actually will complain. It won't let you do two lands. Now, that's not to say you couldn't do two jumps. If, for example, we could have jumping in different parts of the program. A simple little program like this doesn't make much sense, but if I had a much more complex program with some forks and conditionals, things like that, I could have multiple places where I might want to jump, and all of them will come down at the same land, which does make sense. You could actually jump from different parts of the program and land in the same place. There are 5 basic jumps. There are the red, blue, yellow, green, and black. If you want more, you can use a generic jump land pair. And just to let you know that there is a numbering scheme. That's the word I'm looking for. So jump number 0 is the same as the red jump. So jump number 0 is the same as red jump. Jump number 1 is the blue. 2 is yellow. 3 is green. Black is 4. So if you actually run out of jumping jumps, you'd actually start with 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5 would be your first generic jump. And of course, you have to actually have a matched jump pair land. So you'd actually come in here and wire these, for example, together. And now I can put this in my program. If I do these guys, I can put this in my program with a little bit auto wiring. A little auto wiring there. And there we go. Now I have a program which basically repeated over and over and over, turning the motor on for 1 second, turning it off for 1 second, using this generic jump number 5. A common mistake is that students think it'll jump 5 times. This is not a loop. This is an infinite loop. This will jump over and over and over and over. The only way to stop this program is to physically push the run button or turn the RCX off in this case. Okay, so this is not 5 jumps. This is jump number 5. That's a common mistake.